Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 2 in a session October-November 2021 Paper 2-1. So let's start with the first question. Question number 1, find the exact value of this integral. So let me integrate this. We have 4 e power 2x divided by 2 minus 2 e power minus x over minus 1, and the limits are minus 1 to 2. So this would be 2 e power 2x plus 2 e power minus x. The limits are minus 1 to 2. Substituting the upper limits, we have 2 e power 2 times 2 plus 2 e power minus 2 minus the lower limit is 2 e power 2 times minus 1 plus 2 e power negative minus 1. Okay, so this would be 2 e power 4 plus 2 e power minus 2 minus 2 e power minus 2 minus 2 e power 1. Okay, so 2 e power minus 2, 2 e power minus 2 with a positive and negative sign, this is cancelled. So we are left with 2 e power 4 minus 2 e. Right, so that is the value of the exact value of this integral. Question number 2, part A, sketch on the same diagram the graphs of y equals to 3x and y equals to absolute of x minus 3. Okay, so let me consider both functions and find out their x and y intercepts first. So if I have the first function y equals to 3x, right? So for x-intercept, when y equals to 0, what is the x value? X would be equals to 0. When y is 0, 3x is 0, so x is 0. When x is equals to 0, the y value is also 0. So we have just a straight line. Or we can say the y-intercept is 0 and the slope is, which is rise over run, is 3 over 1. Right. Okay, now considering the second function without absolute, y equals to x minus 3, finding the x and y intercept. When x is equals to 0, y value is negative of 3, right? When y equals to 0, the x value is 3. Right, let me sketch the graph. First we have to make the grid. 3 and negative 3, so we need to do the absolute, yes. Okay, this should be the shape. Okay, in terms of centimeter, if I consider this as 1 2 3 4 5, and this side I can take as, this is 1 2 3 4 5, and minus 1 minus 2 minus 3 minus 4 and minus 5, right? All right, so the first equation, y equals to 3x, we have the y-intercept is 0 and the slope is, rise is 3 units, so 1 2 and 3, and the run is 1 unit, so this would be the point. Right, connect the 2 points, we will get the graph for this curve. Equation y equals to 3x, right? Okay, now for the second one, we have the x-intercept. When x is equals to 0, y value is negative of 3, but we have to take the absolute of y because the y function is absolute. So absolute of negative 3 is basically positive 3, right? So when x is 0, y value is 3, so x is 0, y is 3, 1 2 3, this point. And when x is equals to, when y is 0, the x value is 3, 1 2 and 3. This is a vertex, right? Let me take another point on the curve. So when x is equals to, let's say 5, what is the y value? Absolute of 5 minus 3, which is 2. This is x equals to 5 and y equals to 2. y equals to 2 is over here. Yes, this point. Okay, let me sketch this. The v-shaped graph for the absolute function. This one. All right. Now for part B, find the coordinates of the point where the two graphs intersects. Right. So as you can see, the two graphs intersect at one point. So that would be the point of intersection. This is the point of intersection. So we can say we need to put both the functions equal. So we can say 3x is equals to absolute of x minus 3, right? Or we can say 3x is equals to plus minus x minus 3. So let me do scaling on both sides in order to get rid of this plus minus. Scaling on both sides. Okay, so this would be 3x whole square. This would be x minus 3 whole square. So this is 9x square, this is x square plus 9 minus 6x. Right, shifting all the terms to the left side. So this is x square minus 9x square minus 6x plus 9 equals to 0. So that would be minus 8x square minus 6x plus 9 equals to 0. Or let me take a negative sign common. So we have 8x square plus 6x minus 9 equals to 0. Right, now let me factorize this. Okay, so we can say 8 times 9 is 72 and 12 times 6 is 72 and 12 minus 6 is 6. So 8x square plus 12x minus 6x minus 9 equals to 0, right? Let me take 4 common. 4 and x. 4 times 2 is 8 x and 4 times 3 is 12. Negative of 3 is common. 3 times 2 is 6, 3 times 3 is 9 equals to 0. So the two factors are 4x minus 3 and 2x plus 3 equals to 0. So the two values of x are x equals to 3 by 4 and x is equals to minus 3 by 2. So we are not considering the negative one because as you can see the point of intersection lies when x is positive, right, and y is also positive. So we have to consider the x value, which is 3 by 2. This is only solution. So let me find the corresponding y value. So y is 3 times of x, which is 3 by 4. Y would be equals to 3 times 3 is 9 out of 4, right? So we can say the coordinates, the xy coordinates are x is 3 by 4 and the y is 9 by 4. These are the points of intersection, right? Now for part C, deduce the solution of the inequality. Okay, so same thing, we have to scale. 3x whole square is less than, we have x minus 3 whole square, and when we open the square and shifting all the terms to the other side, this would be minus 8x square minus 6x plus 9. This is less than 0. And okay, so what we have to do, scaling on both sides, right, in order to get rid of this absolute sign or plus minus, right? And then what we did, you have to shift all the terms to the left side, right? So it becomes 9x square minus x square, that would be 8x square, right? And positive of 6x and negative of 9, this is less than 0, right? So we have two roots, which is 3 by 4 and negative 3 by 2, and when it is less than 0, so this is the lower portion is less than 0, right? So it means we have only one point of intersection for x when x is 3 by 4. So x should be less than 3 by 4. That is the only solution. It should be less than 3 by 4. Yes. Question number 3. The variables x and y satisfy the equation a power y equals to kx, where a and k are constants. The graph of y against ln x is a straight line, passes through the points this and this as shown in the diagram. Find the value of a and k, give each value correct to two significant figures. Right, so we have given a power y is equals to kx. Right, so let me take ln on both sides. So y ln a is equals to ln k plus ln x, right? And we have to find y and ln x in terms of a straight line. So y equals to mx plus c is basically a line. Y equals to mx plus c. So m is a slope and x is replacing with ln of x. M times ln x plus some y-intercept, right? So we have y equals to ln k over ln a plus ln x over ln a. Right, so this is y is equals to 1 over ln of a is my slope times ln x plus the y-intercept is ln k over ln of a. Right, we have to solve for a and k. Right, let me substitute the 2 points into the curve. The first point is 1.03 and 6.36. right, so we have 6.36 is the y value and this is ln x value. Right, 1.03 over ln a plus ln k over ln a. Right, now for the second point we have given is 2.58 and 9.00. so this is 9.00 is the y value. 6.258 is your ln x, right, over ln of a plus ln k over ln a. So we have two equations. Let me subtract the two equations. So we need to change the signs for subtraction. If we are subtracting the two equations, we have a negative sign, negative and negative over here. So ln x over ln a, positive and negative sign is just cancel out. We have 6.36 minus 9.00. This is negative 2.64. This would be equals to 1 over ln a is common. We are left with 1.03 minus 2.58. This would be minus 1.55. Okay, so to solve for ln a, what we have to do, cross multiplication. Ln of a is over here, negative sign is cancelled with negative. 1.55 divided by 2.64. so 1.55 over 2.64, this would be 0.587, 0.58712, and we have to solve for a, which is e power of 0.58712. so e power answer, this is up to two significant figures we have to solve. So the a value is 1.8. so from here a is equals to 1.8. Now let me substitute this ln of a value or the a value into first or second equation to solve for the k value. Let me substitute it into the first equation. 6.36 times ln a is equals to 1.03 plus ln k. 6.36 times 1.703 ln of a value is 0.58712. this is 0.58712, and then subtract 1.03. this would be ln of k. Right, let me calculate this. We have 6.36 times 0.58712 and then subtract 1.03. this is ln k. So ln of k is 2.7041. And taking exponential, we will get the k value, which is 14.9, or we can say 15. Up to two significant figures, the k value is 15. Question number 4, the curve with equation y equals to this has a minimum point m. So the minimum point is a point when the first derivative should be equals to 0. Show that the x-coordinate of m satisfies the equation. This would be the x-coordinate. So we need to find y prime, which is the product rule. First function is as it is, derivative of second function, plus second function is as it is, derivative of first function, plus 5 e power minus x, its derivative is minus 1. So this is 2x e power 2x plus e power 2x minus 5 e power minus x, right? So to find the x coordinate, we have to put this equals to 0. So we can say for minimum point y prime should be equals to 0, right? So we can say 2x e power 2x plus e power 2x minus 5 e power x minus x, this should be equals to 0, right? Or we can rewrite 2x e power 2x plus e power 2x minus 5 over e power x equals to 0, multiplying by e power x. So 2x e power 3x plus e power 3x minus 5, this should be equals to 0, multiplying by e power x on both sides, right? Okay, now let me take e power 3x common. We are left with 2x plus 1, and shift the 5 on the other side, it becomes positive 5. We have to make this form basically. Okay, then we can say that now let me take ln on both sides. Ln of e power 3x plus ln of 1 plus 2x equals to ln 5, right? Now ln of e is 1, so we have 3x should be equals to ln of 5 minus ln of 1 plus 2x. Then what is x? X is equals to 1 over 3 ln 5 minus 1 over 3 ln of 1 plus 2x, right? So this m set is x coordinate of m satisfies this equation. Now for part B, use an iterative formula based on the equation in part A. So the equation is xn plus 1 is equals to 1 over 3 ln 5 minus 1 over 3 ln of 1 plus 2xn. To find the x coordinate of m correct to three significant figures, use an initial value of 0.35. So x naught we have given 0.35, and give the result of each iteration to 5 significant figures, right? Let me make a table of values here. 5 significant figures, all right. So if I can say this is for xn and this is for xn plus 1, so the initial guess we have given is 0.35 x naught. What is xn plus 1? Let me calculate this. So this is ln 5 divided by 3 minus ln of 1 plus 2 times 0.35 divided by 3. This is 0.35 up to 5 significant figures, 1 2 3 4 5 3 5 9 6 and 0, right? So again ln 5 divided by 3 minus ln 1 plus 2 times 0.35960 divided by 3. This is 0.3558 1 2 3 4 5, this would be 6. Okay, ln of 5 divided by 3 minus ln 1 plus 2 times 0.35586 divided by 3, 0.35731. All right, Let me do another one. Ln 5 divided by 3 minus ln 1 plus 2 times 0.35731 divided by 3. 0.35675. Okay, let's do one more. Ln 5 divided by 3 minus ln 1 plus 2 times 0.35675 divided by 3. 0.35697 and so on. Let me fill this column as well. 0.35960, 0.35586, 0.35731, 0.35675 and so on. Okay, we need to find the x coordinate of m correct to 3 significant figure. So we can say that x coordinate of m is 0.35. This is fixed. 0.35353535. It's 9 and 5. This rounded, 9 round to 10, this rounded to 6, and then 7 7 7, so this rounded to 7. So 0.357 is the x coordinate of m. Question number 5. The diagram shows the curve with the parametric equation x in terms of t and y in terms of t. The curve crosses the y-axis at point A and the x-axis at point B. Right. So the coordinates of point A are 0 and y, and for B we have x and 0. Right. Now for part A, show that dy over dx is equals to this. So we have to find dy by dx. So first we need to differentiate dx with respect to dt. So this is 1 over 2t plus 3 times 2. This is 2 over 2t plus 3. Right. Now let me find dy over dt as well, which is the quotient rule we have to apply. So the denominator function square, the denominator function, the derivative of the numerator function is 2, minus the numerator function 2t minus 3 and the derivative of denominator function. Let me simplify this further. This would be, if we can take 2 outside, we have 2t plus 3 minus 2t plus 3. These 2's are outside, and this is divided by 2t plus 3 whole square. 2t and minus 2t's cancel. This is 3 plus 3 makes 6, and 6 times 2 is 12. 12 over 2t plus 3 whole square. Now let me apply the chain rule. Dy over dx, this should be equals to dy over dt times dt over dx. Okay, so we have dy over dt is 12 over 2t plus 3 whole square times we have 2t plus 3 divided by 2. Right, so we can cancel 2t plus 3 and 2 with this 6. So the simplified answer we got is 6 over 2t plus 3 for dy over dx. Now for part B, find the gradient of the curve at point A. So this is the point A, and we know that the curve crossed the y-axis at point A, so means the x should be equals to 0, and we have to solve for t because the gradient dy over dx depends on t. Right. So x we have given is ln of 2t plus 3. Right, x is 0. We have ln of 2t plus 3, and taking exponential e power 0, which is 1, and this is equals to 2t plus 3. Right, or from here we can say 2t equals to 1 minus 3, and 2t would be equals to negative 2, and t would be equals to minus 1. Right, now what is dy over dx? at t is equals to -1, which is 6 over 2t plus 3, right? This would be 6 over -2 plus 3. This would be 6 over 1. This is 6, right? Now for part C, find the gradient of the curve at B. So at B, you can see the curve cross x-axis at point B, means the y should be equals to 0. So we can substitute y equals to 0 and solve for t. So we have y is equals to 2t minus 3 over 2t plus 3. So we can substitute y equals to 0. So 0 would be equals to 2t minus 3 over 2t plus 3. So cross multiplication gives me 2t minus 3 equals to 0, and t would be equals to 3 by 2. So we have the t value. So dy over dx at t is equals to 3 by 2. This would be 6 over 2 times 3 by 2 plus 3, right? So 2 is cancelled with 2. 3 plus 3 is 6. So this would be 6 over 6. That would be 1. So the gradient of the curve at point B is 1, and at point A, the gradient is 6. Question number 6. The polynomials f of x and g of x are defined by f of x and g of x, where a and b are constants. Part A, given that x plus 3 is a factor of f of x, find the value of a. So x plus 3 is a factor of f of x. It means f of -3 should be equals to 0. So 4 times -3 whole cube plus a minus 3 whole square plus 8 times -3 plus 15, this should be equals to 0, right? So -3 cube times 4 is -108, and -3 square is 9 plus 9a minus 8 times 3 is 24. 24 plus 15, this is equals to 0. So 9a and minus 108 minus 24 and plus 15. This is minus 117. This is equals to 0. So 9a equals to 117, and a equals to 117 over 9. 117 divides 9. A value is 13. Right. Now for part B, given that the remainder is 40 when g of x is divided by x minus 3, find the value of b. So it means g of x minus 2. G of 2, this should be equals to 40, right? So let me find g of 2, which is 2 square plus b times of x plus 18. This is 40. 2 square is 4 plus 2b plus 18. This is equals to 40. So 2b, this would be 40 minus 18 minus 2 minus 4, sorry. Okay, so 40 minus 18 minus, sorry, 40 minus 18 minus 4, 18. So 2b equals to 18. 18 divided by 2, b value is 9. All right. Now for part C, when a and b has these values, a is 13 and b is 9, factorize f of x minus g of x completely, right? So f of x minus g of x, this is f of x is 4x cube plus ax, which is 13x square, plus 8x plus 15. Subtract g of x is x square plus bx. B is 9x plus 18. So this is 4x cube plus 13x square plus 8x plus 15 minus x square minus 9x minus 18. So 4x cube, 13 minus 1 is plus 12x square. 8 minus 9 is minus x, and 15 minus 18, 8 minus 9 and 15 minus 18 is -3. Right. Let me use a method of synthetic division over here. Okay. Let me write down the coefficients. So the coefficients for x cube, x square, x, and the constant. Okay, if I can say, we have given that x minus x plus 3 is the factor of f of x. Okay, so if I use this, maybe negative 3 is the factor. So if I can take negative 3, bring 4 down. 3 times 4 is 12, minus 12, this is 0. 3 times 0 is 0, minus 1. 3 times 1 is 3. So this should be equals to 0, right? Okay, so we can say this would be x plus 3 into 4x square minus 1, right? So we can rewrite this x plus 3 into 2x plus 1 into 2x minus 1. So this is the complete factorized form of f of x minus g of x. Moving to part D, hence solve the equation f of cosecant theta minus g of cosecant theta equals to 0 when theta is between 0 to 2 pi. F of x minus g of x equals to 0. So when we have f of x minus g of x, this is equals to 0. It means x minus x plus 3, 2x plus 1, and 2x minus 1 is equals to 0, right? So if I can replace x with, we can say x is equals to cosecant theta, right? So we have the three factors. We can say cosecant theta is negative 3, cosecant theta is negative 1 by 2, or cosecant theta is 1 by 2, right? Cosecant is basically 1 by sine, or so you can say sine theta over here is 1 over 3, and sine theta over here is negative 2, and sine theta is 2. Okay, so sine, if I can say sine inverse of 2, because these two are not defined, because the range of sine is between -1 to +1, so these two are undefined. Right, let me solve the theta value from here. So theta is equals to sine inverse of 1 over 3. In terms of radians, we have to calculate, the domain is in radians, my calculator is in radians. Sine inverse 1 over 3, which is 0.3, this is minus 3, sorry, 0.3398. So this would be 0.3398. Okay, and sine is negative in which quadrant? Sine is negative in third and fourth quadrant, right? For third and for fourth quadrant, we can solve the theta value because the domain is between 0 to 2 pi, right? So for third quadrant, we do pi plus theta. So we can say pi plus answer is 3.48. And for fourth quadrant, we do 2 pi minus theta. So 2 pi minus 0.3398, 5.94. And these two values are in the range 0 to 2 pi. Now question number 7, part A. By first expanding cos 2 theta plus theta, show that cos 3 theta is equals to this. So cos A plus B is cos A cos B minus sin A sin B. So this would be cos 2 theta cos theta minus sin 2 theta sin theta. Right, we have to show cos 3 theta should be equals to this. Okay, so cos 3 theta, this is everything is in cos. So let me convert. Cos 2 theta, cos theta, sin 2 theta is 2 sin theta, cos theta into sin theta. Cos 2 theta, cos theta minus 2 cos theta, sin square theta. Sine square theta in terms of cos is 1 minus cos square. So cos 2 theta, cos theta minus 2 cos theta into 1 minus cos square theta. Everything is in cos now. So cos 2 theta and cos theta minus 2 cos theta plus 2 cos cube theta. All right. Okay, this is 2 cos cube theta. This is cos theta. Cos theta, we have to convert this, open the cos double angle here. So cos 2 theta in terms of cos is 2 cos square theta minus 1 into cos theta minus 2 cos theta plus 2 cos cube theta. So this is 2 cos cube theta minus, not 2, just cos theta, and then minus 2 cos theta plus 2 cos cube theta. So this is 2 plus 2 makes 4 cos cube theta, and minus 1 minus 2 is minus 3 cos theta. This is proved. This is cos 3 theta. Cos theta plus 2 theta makes 3 theta. This is the answer for cos 3 theta. Right. Now for part B, find the exact value of 2 cos cube of this minus 3 by 2 cos of this. Okay. So if I compare this with, we know that cos of 3 theta is given 4 cos cube theta minus 3 cos theta. Okay, so if I can divide it by 2, yes, on both sides. So 1 by 2 cos 3 theta is, we have 2 cos cube theta minus 3 by 2 cos theta. All right, minus 3 by 2 cos of something plus 2 cos cube of something, right? So this implies we have theta is equals to 5 pi over 18, right? So if I can rewrite 1 by 2 cos 3 into 5 pi over 18, this is equals to 2 cos cube 5 pi over 18 minus 3 by 2 cos 5 pi over 18. All right, so this whole thing is basically, we have to solve for this, right? Let me use a calculator for this. We have 3 times 5 divided by 18, 5 by 18 times by pi, and cos of answer, and times 0.5. This is minus square root of 3 over 4. So this 1 by 2 cos 3 into 5 pi over 18, this is equals to minus square root of 3 over 4. All right. Part C, find the integration of 12 cos cube theta minus 4 cos cube 3 theta dx. Okay, so if I can use the identity from part A, we have given that cos of 3x is equals to 4 cos cube x minus 3 cos x. What is cos cube x? Cos 3x plus 3 cos x. This is equals to 4 cos cube x. Dividing by 4, 1 by 4. So this is cos cube x, right? So if I multiply it by 12, so we have 12 over here. So we can do 12 times by 12 and 12. So we have 12 cos 3x. This is equals to 4 times 3 is 12, 3 cos 3x. And if I can say 12 times 3 divided by 4 is 9, plus 9 cos x. This we have to use over here, right? All right, now we have to use 4 cos cube 3x as well. So from here, cos cube x we have given is 1 over 4 cos 3x and plus 3 over 4 cos x. All right, so if I replace x with 3x, so cos cube of 3x is 1 over 4 cos 3 and 3x. 3 times 3 is 9x plus 3 by 4 cos 3x and times by 4. So we have to do times by 4 cos cube 3x is cos 9x plus 3 cos 3x over here, this value, right? Let me substitute for the integral. Integration 12 cos cube x, right? So 12 cos cube x value is this. So we have 3 cos 3x plus 9 cos x minus 4 cos cube 3x. 4 cos cube 3x value is this, cos 9x plus 3 cos 3x dx, right? 3 cos 3x plus 9 cos x minus cos 9x minus 3 cos 3x dx. 3 cos 3x positive and negative is cancelled. We are left with 9 cos x minus cos 9x dx. The integration of cos is sin x minus sin 9x over 9 plus some constant of integration. This is the exact integral, right? So that was the last question of our paper. If you have any queries, please let me know in the comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.